Welcome to AJ Ferrara and Brian Linton's Circuitry Special.
I am Brian Linton.
And I'm AJ Ferrara. So here is our Wheatstone Bridge circuit that we set up. We have R1, which is 1.8 kiloohms, R2, which is 3.9 kiloohms, R3, which is 1 megaohm, and RS, which is 2.2 kiloohms. Over here we have a potentiometer which we'll change the resistances to create a voltage difference between across R3 to be 0. So we have the circuit plugged into the function generator. We'll hook up the probes and use the program waveforms to find the correct potentiometer resistance that will create a 0 voltage across resistor 3, which will help us solve different elements of the circuit. So I will set up the probes while Brian goes onto the waveforms and gets things set up.
Here's waveforms. We have wave gen open, which is generating a wave of 5 volts with a frequency of 1 kilohertz. There's also a peak-to-peak difference of 10 volts. And we have our scope open. We have one for channel 1, one for channel 2, and one for C1 minus C2. That would be the red line. So we will be using the potentiometer to optimize the value of the red line or make it as straight as possible so that the difference between channel 1 and channel 2 is minimal. So when we adjust the potentiometer.
Yep, so the probes are hooked up so we can check the voltage difference across R3, and as we change the potentiometer, you can see the red line will change, and also the blue will change because that is changing the voltage across the resistor, and the red will correspond being the difference. And as straight as we can get it, let's see if we can get it to a straight line, and that is pretty close to straight right there.
And you can see we have our peak-to-peak difference of about 6.69 millivolts. And we need to find the minimal value because that allows us to find the value of the resistance of the potentiometer that gives us a voltage difference across R3 of 0.
Yeah, perfect. Yeah.
That's our circuit.